Today I'm going to talk about practical stuff. So I don't work for Microsoft Research, and I work on a product team, so real things. But before I move forward, the usual disclaimer, these are just my opinions, have nothing to do with Microsoft. This is joint work with a bunch of folks, current and former Microsofties from the Bay Area and also from Redmond. The outline, I'm going to give a quick overview of what do I mean by label quality in the context of big data and machine learning. I'm going to talk about wet programming, which means how to program people. Real problems. We're going to mention algorithms for managing crowds and quality control, and then a few takeaways. You can interrupt me at any time. I'll give the slides back to you. I have a lot of examples, and every slide usually has a paper, so plenty of takeaways. Okay, a bit of a context here. So we're going to assume a supervised or semi-supervised learning setup, which means that we need a human somewhere, either to help us create a training set, to help us evaluate an output of an algorithm, or to signal something. So there's somewhere a human. Obviously, this is going to be different from normal users because the users are not interacting on a real system, but it's basically on a bit of a synthetic system. And we're going to ask experts or users to do stuff for us. I'm going to add two constraints from productions and from real stuff. The first one is scalability. Okay, so I don't want 100 labels for publishing a paper or just running a demo. This is about thousands of millions of labels. And the second is continuity. It's not a one-shot. So this is not a one-off exercise. This is a daily, monthly, or weekly activity. Depends on your domain. Okay, so the last two are very, very important in production systems. Why we need data and why we need labels. If you happen to work on machine learning, most of the stuff for building feature engineering and for building training sets, it's about data and labels. If you work on data science, analyzing data involves analyzing high quality data and analyzing how people label those data sets and how can you use them for something else. And finally, whatever you do, at some point you need to measure things. And you need to measure precision recording in search engines, real search curves, whatever you want, but you have to measure something. Data skin, so we already know this. There's a ton of free data available on the web that you can use to train, in particular, learning systems. And crowds, and when I say crowds here is all of us. We can use anybody in the planet to do cheap labeling for data. And I cross big data because this is just data. Okay? Forget if it's small, big, medium. It's just label. And you need good labels for data. But also the quality is super important here. You may remember garbage in, garbage out. So we want to minimize the amount of garbage that we put into these systems. And I included three, I don't know if you can read them, but there are three references of people who talk about label data and machine learning. And I really like an article that Pedro Domingos wrote on ACM a couple of years ago, which he mentioned in one of the sections of the paper. It's all about feature engineering and dealing with data. Okay, so you spend most of your time cleaning data, deduping data, managing data, wrangling data, and not a lot of time on the machine learning part. Okay, so this talk for the next 35 minutes is about the boring stuff, not about the cool stuff about machine learning. What is a label? Label basically means that I'm going to assign some sort of a category or some sort of a value to a particular class. In the case of a relevance evaluation task in building a search engine, I can have the query text by the bay, and then I have the homepage of text by the bay, and I'm going to ask, is the page relevant? And I need three types of labels that says, yes, it is very relevant, somewhat relevant, or not relevant. Then you have examples like spam in emails, and I have a potentially spammy email message, and I'm going to say, this is spam, yes, no. So those are the things that you collect as labels. However, this is not the whole story. And let's talk a little bit more about the importance of labels, and this is kind of important, right? So say that I have to label a set of documents in the context of information retrieval, which means building a search engine. And I'm from South America, I love soccer, I love meat, So I have my own judge characteristics, right? And then they show me a bunch of documents, and I'm gonna be judging those documents, okay? I produce a judgment. But then Peter and Bob are gonna do the same for the same document, for the same query. And at the end, we'll produce what we call a creation of a label. That is a label, okay? We're gonna use that label to learn a model. When we know that, then you can predict labels for the rest of the collection. Why? Because we cannot label the entire World Wide Web. We're going to label a subset. And then we're going to use a machine learning model to label the rest. Once you can do predictions, then you can evaluate and see how good your algorithm is. Why I'm doing this? Because if you don't put the right labels as you start on this workflow, you're going to learn the wrong things. You're going to predict the wrong things. And you're going to evaluate the wrong stuff. Okay? So hugely important to make sure that your labels are of high quality. What do we mean by label quality? So data gathering is not a free lunch. Okay, so you have to own it. You cannot outsource label quality. We're going to talk about crowdsourcing, but do not outsource the acquisition and label quality. Labels for the machines are different from labels for the humans. Okay? And if you talk to anybody who is working on ML, basically, there's an ML engineer who is going to build the classification task or clustering or whatever you want. And he or she needs a particular set of labels for Weka or some sort of open toolkit. And then they're going to reverse engineer the task for people. Okay? So it says, oh, my system needs X, Y, and Z. Then I'm going to take X, Y, and Z, make a form so people can give me those labels. Wrong. There's certain scheme of labels for people, and then you have certain scheme of labels for the machine. And we need to talk about that shortly, but they're not the same, okay? So if you need yes and no, that doesn't mean that people are going to say yes and no. And I'll show examples of this. I was talking with some folks before the talk, and there's always a lot of emphasis on algorithms, models, optimizations, and mining from the labels. So when you talk to anybody who's working in machine learning, it's like, oh, I'm an SVM guy, or I do neural networks, or I like this, some sort of optimization model, et cetera, et cetera. But nobody talks about this, okay? How can I use algorithms to make sure that I get high quality labels? The last part is the boring stuff, right? This is super important if you're going to build training sets, okay? Extremely crucial if you're going to build training sets. So careful with that data. In the area of big data machine learning, like I said, the workflow is you have some labels, you're going to compute some features, you're going to build a predictive model, and then you're going to optimize. That's the workflow. Everything that is labeling and experimentation is perceived as boring. But we're going to say do not rush labels. We're going to talk about the difference between humans and machines. And as I said before, do not outsource it. You have to own it end to end. And more important, if you're going to do it at large scale, you have to really own it end to end. Okay, enough for kind of the motivation for the talk, so let's just get into more details. Wet programming, or how to ask people to do stuff. Okay. Human computation. This is kind of the label for this area. I'm going to use humans as processors in a distributed system. A worker, a rater, an annotator, a judge, are kind of different names for a person doing stuff for us. Now, people are very good at doing and basically solving problems that computers are not good. And in case you don't know, all of us, we are computers. So every time you log into Facebook and like a page, you are computing something for Facebook. Okay? Every time you retweet, you are probably helping the Twitter algorithm to detect a trending topic. Every time you enter a query in Bing or Google, you're just giving me data so I can show you better results. So all of us are computing things. A few years ago, Louis Bonan, when he did his PhD at CMU, he coined the term human computation and all this notion of games with a purpose. So what about playing, like annotating images with labels? They're going to use that data for training systems. Known platforms today are Amazon Mechanical Turk and Crowdflower, which are probably the two most popular platforms on how to collect data. At Microsoft, we have our own platform. Briefly, I'm going to mention about that. But basically, if you want to run any human computation today, you go to mTurk or you go to Cloudflower, and then spend a few cents, a few dollars, and get your labels. And why this is interesting? Because it's extremely easy to prototype and test new experiments. Very, very easy. Okay, you don't have to build anything. The platform is there. You just create a task, upload data, collect the labels. You're done. So cheap and fast. There's a lot of papers on cheap and fast for NLP, cheap and fast for machine translation, etc. This allows you to introduce experimentation early on in the cycle. So if you're developing stuff, as you develop, you do all these experimentation, all these labeling gathering tasks. Allows you to implement an experiment as you go. So you test something didn't work, you go back to the whiteboard, redo the experiment, redo the labels, etc., etc. And if you get new ideas, this is extremely useful because you can move very, very rapidly. However, humans are different from machines. Okay, so the instruction set for a human is somewhat unknown. Okay, the instruction set for a machine is well known: add, subtract, move, jump, move to the register. For humans, it's like, yeah, I can add 2 plus blue, but don't ask me to add, decimals with, 7-point digitals, because I'm not going to do it. It's very, very difficult for that. Machines are very quick. Humans, latency, not so quick for certain things. You don't have to pay a machine, you have to pay a person. Assuming your algorithm is correct, there are no errors in the machines, unless you have a hardware problem, but humans, we do make a lot of errors. There's not a concept of a task difficulty in a machine. There's a lot of concepts of task difficulty for humans. And then there's a bunch of human factors. I'm being boring, I'm tired, I'm sick, I don't want to do this, I'm going to do it in a sloppy way, etc., etc. Welcome. So how can we ask questions? Asking questions to people is basically part of an art and part of science. Okay. Instructions are obviously key. You have to know how to ask questions. And in the case of your domain or your mTurk or your Cloudflower, the workers are not experts, so you cannot assume they know exactly everything about what you're trying to do. Probably they don't. Okay? You have to always show examples and always try to hire a writer, because the engineer will write the specification, but you need a writer who is going to write the communications to people. And this is a very common mistake. People just do not do this. Basically, you have a developer who's going to write instructions on how to do stuff. And guess what? It's not going to work. The second part is user interface design. So you probably have learned this at grad school or undergrad, or you have an idea of how to design a good user interface, right? So the experiment or all the tasks, they have to be self-contained. You have to keep it short and simple, okay? Short and simple, very clear what you need to do, what you don't need to do. Engage with the worker, do this, here's good data. Good presentation at the document level, the same as the design. You need to grab attention. You're working and competing with other workers trying to do stuff as well. And always ask for feedback. So if something is not working, just ask, is this clear, is it not clear, what I'm doing wrong, etc. Localization is also a problem. You may have tasks that, say spelling correction in English, French, Spanish, and German. It's much better to get the task first in English, making sure it works, and then you do the localization. Not do everything in parallel, because it's not going to work. Other principles, text alignment, legibility, reading level. Some stuff is easy to read, some stuff is very difficult to read. There's multilingual, multicultural issues, basic stuff, people with colorblind problems, and then the mental rigor to perform a task. Not everything is straightforward. Some stuff it's pretty difficult. Another area that people kind of don't take a look is this notion of exposure effect, which is if I show you the same document and the same query over and over time, you're going to start liking it, when the first time you didn't like it. So kind of randomizing the content and make sure that always there's fresh things to judge and label is good. Okay, so far so good, just to build in a task. The other part is quality control in general. So the quality control problem is basically bidirectional. So there's quality control for the workers, but there's also quality control for the requesters. Okay, so you may think that the worker is doing a bad job, which is basically the de facto approach. Okay, you don't get good labels, you blame the workers. They're bad. but maybe the workers, perceive that you're extremely lousy requester because you're not clear on what needs to be done. So always treat it as a bi-directional problem. And again, everything I'm saying here is not just for crowdsourcing, but this is for human raters, judges in your company, annotators, etc. Same. When to assess work quality. So basically, you have 3 checkpoints before. So before you start the task, you're going to assess quality, usually using qualification test or a similar mechanism for training. Okay, so the goal is to screen, select, recruit. While people are doing work, you're going to assess labels. So as I click yes or no, you're going to do a random check. Did I pass the honeypot? Did I miss? Did I agree with the rest of the majority? How am I doing, right? And after that, then you're just going to compute how I did on the entire task, how I compare to my peers, how I compare to my past performance. And why we need this? Because at the end of the day, what you want is to make sure that the labels that you're getting from people have high agreement. And this is key. Okay, so you want to measure agreement, reliability, and validity. In statistics, it's called inter-agreement. An inter-agreement is between judges, so you can have 2 experts, and then I'm going to measure if the 2 experts agree on a particular label, or I can measure an expert or a judge or a worker against a goal set. And you can use Cohen's kappa, which is a well-known stat for 2 raters, Fleisch, which is an extension for any number of raters, or Krippendorf, which is any number of raters, and in certain cases you have missing values, you can use that. Okay, this is solid, and please use these things. Okay, don't say, oh, I just got this, and looks like the stuff is cool, and looks like it's decent. No, solid statistics for getting these things. And we're going to see that what happens when you don't achieve agreements, and what are the problems on that. Other practical tips, you're going to sign up as a worker in your company or in a platform, do some work. You have to eat your own dog food. If there are problems like poor guidelines, the payment is low, etc., you have to address, and everything counts. A bit of the human side, as a worker, you hate when the structures are not clear. You're not a spammer, but you just don't actually understand what you're supposed to be doing. The task might be boring. It's always good to get a good pay, but sometimes it's always good to have something really cool to do because I'm going to learn something. Now, as a requester, what you want is attrition, to manage your attrition, because you need people who actually do the labels for you always. And it's a balancing act because you want to get the right results, but at the same time, you want to have a cool task so workers can do things for you. And sometimes you just want honest answer. I don't care. Don't try to be good to me. I just want your honest answer. Maybe the document is not relevant. Just tell me it's not relevant. It's not good. We want that. You also want qualified workers, but there's a lot of problems in the platforms today to kind of pre-select qualified workers. We're going to talk this about later. And managing crowds and tasks is usually a daily activity, and is much, much difficult than managing a data cluster, okay? Because all these things change on a daily basis. And then you're going to run into other issues. This is a great article that appeared a few months ago, last year, on Wire magazine, and it's about how Facebook is using a company in Philippines to sanity check that every picture is good. So when you get into your Facebook feed, you don't see any surprises. The article is great because it goes into kind of the dark side of human computation, which a lot of people have to look at these things that are not going to be useful or for them, obviously, but the company needs the labels to train their rankers. Okay, so far, this looks very good, but, looks like a ton of work. And, the original goal is to, provide good labels. So data quality and experimental designs, in our case, are kind of preconditions to make sure that we got the right stuff, because the labels are going to be used for rankers, machine learning models, evaluations, etc. So please do not cut corners. Now we're going to move into the real stuff. Okay. So far I've been saying do this, do that, but I'm going to kind of put the money where my mouth is, and I'm going to say, this is exactly how you do it in real life. And this is the framework that we use in production. You can go to this paper, Information Retrieval, that explains this in detail. But the goal is the following. You start with a particular labeling task, whatever is the labeling task, okay? So the first one is the prototype development. You have a very small data set. It's your internal team, 4 people, your internal team, okay? And it's mainly for testing. So someone builds a design, and you're going to get into the room, and everybody will do labeling. Sorry, guys, everybody will do labeling for 2 or 3 hours, okay? Now, you do labeling, you do your statistical measures, and you say, did we agree on it? Okay, if you didn't agree, back to the whiting board, okay? You don't move. It's not working. Very similar to building a user interface, okay? I don't get it. Where's the pull-down menu? What is this red? What is the hyperlink? If you don't do it correctly, you don't move. Once there's agreement within your team that the task is good, the data they're collection is good, the labels are good statistically, et cetera, then you move into the next stage, which is an early stage production. It's still the small data set, okay? But now we're going to crowdsource. So instead of building the team, you're going to the crowd, okay? You don't care that much about the quality of the crowd yet, but you want to make sure that there's agreement between us, the little team, with the crowd, okay? And this is mainly for calibration. So you're going to calibrate the experiment, the incentives, the data, et cetera. Okay, kind of works more or less. If that works, then you move into the next one, which is then you go in production. Then you are going to partition the data set because you're not going to upload 1 million documents to label in one shot. It's not going to work, okay? You're going to partition by 100 or thousands so far, but you're not going to upload a massive data set. At the end, you want your massive data set, but you're going to partition a little bit of data every day. Okay, you're going to crowdsource this. You're going to put all the quality controls mechanisms that you know. We're going to talk about on the last section. And you're going to continuously evaluate this thing. Okay, so if I upload on Monday afternoon, the data is done, then I evaluate the quality. Okay, if it's not good, I do not upload the second batch. If it's good, then I move forward and upload the second batch. But you do this over time, and you move from design to quality. So you have to build a workflow that get the data, uploads into whatever your crowdsourcing platform is, computes all the metrics. If the metrics are not working, you stop. Okay, if the metrics are working, you keep doing this. Over and over and over. Okay? So let me show you a real example. This is a project that we did a couple years ago on a real problem on a search engine, how to detect near duplicates. Okay? There's a lot of duplicates on the web, and there's a lot of near duplicates on the web. And we thought, hey, this is very simple. I just show you 2 documents, and you have to tell me they are dupes or near dupes, right? Wrong. Didn't work. And this is a near dupe. So there's the green, the yellow stuff is the dupe. The stuff that is not yellow is the near dupe. And you have to read, and there's a lot of cut and paste. This might be a BBC document, this might be a Reuters document. They're talking about the same stuff, and it's actually more or less the same document. And you want to show only one. Okay? On the hit list, you don't want to show both. You just want to show one. Or maybe you cluster them. So how we solve this problem? We use that framework. Okay, so we're going to scale up by crowdsourcing. And we're going to use 2 crowdsourcing platforms. UHRS, which is an internal Microsoft crowdsourcing platform, and Mechanical Turk. And because we found that it was very difficult to detect and evaluate if 2 documents were the same, dupes or near dupes, we partitioned the task. And there are 2 tasks here. The first one is this a document about news? Because even something very simple like, is this a news document, is not clear. You may have a picture of Obama with a footnote, and people say, it's news. You say, no, it's not news. I need a 2 or 3 paragraph. But if you say Wikipedia page, that's not news. So even deciding what's a news article was tough. So how we start? We have one task in Mechanical Turk that will say, is this document a news document? Yes, no. If it's yes, that's a potential candidate for them building a collection of pairs, so then we can detect if the pairs are duplicate or not. If not, we throw the document, okay? So documents labels are the first phase, phase 1. Okay, we sample the documents. Is this a news document or not? If it's news, we go to the second phase. We show the two articles. And then we say, is this about the same story or not? And based on that, we collect the labels. How we did this? the 3 authors, okay, the guys who wrote the paper, 3 of us did this and did this with a small data set to make sure everything works fine. Everything works fine. When that is working fine, then we scale it up. And then we use mturk because it was cheaper to do this, the yes and no in mturk. And we wanted high quality workers, so we use UHRS to do the near dupe. Okay? So 2 tasks, 2 different platforms, same data set. At the end, you want 1 label. It's a near dupe. But here, we just kind of partition into 2 platforms and 2 tasks. So 2-phase approach. Assess the documents that are sampled as pairs, news, not news. And then we do a separate task to assess if the document it's a duplicate or non-duplicate. You follow me? More or less. Here's the actual real designs. And you can go here to this URL. You can download all the source code. And this is source code for the templates. Okay, so the first template looks very, very simple. Here are the guidelines. This is what a document we consider to be a news document. Well, this is not a news document. Here's an example, and you have to tell me, yes, it's a news article. No, it's not a news article. I do not know. There's a broken image, a broken link. I cannot tell. And this is how we assess if 2 documents are near dupes and if one is contained to the other one. OK, so far, so good for just collecting labels. That's the only thing we've done is collecting labels. No quality yet. How I assess the quality? Again, another another kind of circuit, sorry, not circle, another circuit. So we're going to use our own labels as goal sets or honeypots. Okay. So from the first step, we, the authors, will produce the honeypots. The honeypots are injected into the crowdsourcing platform, which is going to basically do the quality controls. We're going to check again our stuff. Then there's a second filter on the labels of the near dupes. And in case there's disagreement, the authors will break the pairs and do a majority vote. Sounds complex, but very doable. Again, we started with the authors. We produced the honeypots. The honeypots are injected into the set that goes into, in this case, Mechanical Turk of what is a news article. Then all the assessments of the news article, pass, no pass. Then we create the pairs. We also have honeypots for the pairs. If you didn't pass the pairs, we, the authors, will resolve the disagreements. OK, so looks like it works. It's a fast turnaround, easy to experiment, a few dollars to test. But you have to design the experiments carefully. I mean, this, as you can see, all these little things takes a lot of time, okay? And every little detail counts. You have to build the workflows, scrape the data, produce everything. You can automate, you're going to build a workflow, but actually it takes quite a bit of time and work. So if you don't design the experiments carefully, you're basically doomed. You have quality problems, you have platform limitations, et cetera. This is kind of the real world, right? The real life. Now, crowdsourcing in production, if you want to scale to millions of labels, and you want to do this continuous execution, you're going to face the following problem. How to debug if your task is working. Okay, so far I show you one task that kind of works. But you're going to have the following problems. How do you know if the task is working? We came up with this framework. It appeared on a conference this year. But you have 3 parallel problems. The work may be boring. The worker may be a spammer, and your task may be ill-defined. You cannot debug this in parallel. Okay. The usual kind of reaction is the workers are bad, remove them. Don't pay them, or pay them more, block them. But that's not the problem. So how do we deal with the problem? We say, well, we need to establish a baseline signal. The first one, we're going to look at work. We're just going to look at the data. How's the data? And we're going to vary the data, genre, recency, news articles, non-news articles, Wikipedia documents, not documents. We just want to play with the data and see if we get some signals or not. after we've done that and say check, the work is not actually a problem, we're going to look at the workers. So check if the worker is reliable. We're going to compare against the crowd. We're going to compare the reliability, spam detection, et cetera, et cetera. Once the workers check are good, we're going to look at the task. Are we asking people to do the right stuff? Can they do this? Can they do it in a separate way, et cetera, et cetera? So I'm going to go through this. The task is on social. Very, very simple. Okay, and how difficult this could be. We're going to classify tweets, and I want to say, I want to build a classifier that will tell me a tweet is interesting. Why? Because there's a lot of noise, there's a lot of duplicates in tweets, and I just want to build an index that is of high quality. That's all. Very, very simple, right? It's a textbook problem. Collect the labels, build the features, put it in Weka, linear regression, or whatever is your favorite classifier. Boom. No. Okay, we couldn't actually get it done the way we want it. Because it's, first of all, a subjective activity. And then we found that we couldn't move the needle on the inter-reader agreement. It was like just not working. We were able to build something, but it was just not there. And we tested many designs, 2 different crowd platforms, Mechanical Turk, UHRS, and we just couldn't move. So we go back to our framework and start debugging the task, okay, one by one. And we came with this idea that we borrow from CAPTCHAs, from reCAPTCHAs, and we call this a hidden. So if you're obviously familiar with the CAPTCHA, you have these control terms. So one of those terms, it's well known, the other one is not known, and you have to pass the test, okay? So we're going to use the same. So we're going to adapt the concept of a control term to CAPTCHAs. We build this notion called hiddens, human intelligent task, data-driven inquiries, so you can automatically build these things. I'm going to ask 2 questions. One is an algorithmic question, so you can pre-compute the answer before you upload the test, and the second is a semantic question that is slightly more difficult. Okay, you're very puzzled, but it's not that complicated, okay? So here's a tweet. This is the real tweet, okay? So it's a tweet that is debranded, so there's no face, nothing, just a tweet, 140 characters. The main question is here, but we don't ask this question. We're going to ask it later. The first one is how many hashtag words, so words that begin with a hash, are in this tweet, okay? No hashtags, 1, 2, or 3. Okay, so you have to, as a worker, you have to read the tweet, say up, and then input your answer. And the second is, does the tweet name a specific person? Again, you have to read the tweet, answer the question. And then, yes, our question, do you think the tweet is interesting or not? That's what we want. So we inform people to read this at least twice, answer these questions, and then, what we're looking for. I'm going to measure our inter-reader agreement. Okay, for question 1 is perfect agreement. Question 2 is a little bit less because you have to know that Paul Allen is a person, etc. Smell of victory, right? No. Bomb. Okay, it's just like, what's going on? Well, it's very clear. So these are not spammers. People are just passing the questions, but there's something else here. So this question, do you think the tweet is interesting to a broader audience? Yes, no, it's not working. That's what we want, but for the workers, it's not working. So we're going to desegregate this. Okay, so we're going to go back and say we're going to leave question 1 and question 2, but here we're going to use what we call labels for the humans. Okay? So the labels for the machines, yes, no. We're going to go labels for the humans. Now, these are more human-readable labels. Please check all the boxes that apply to this tweet. Could be worthless, trivial, funny, makes me curious, contains useful information, or it's important news. Okay, we pass, and then we are getting some signals. Okay, and I do not claim this is perfect, but at least we know, right, that on the K levels, alpha levels, of important news and worthless, hey, we're getting something. Maybe this stuff doesn't cut it, but at least I know that people can detect what is an important news and what is junk or crap. That's good enough to build something. But it wasn't good enough to say yes and no. Okay? How am I doing in time? Sorry?
You have 7 minutes.
7. All right, findings from the designs. There were no quality control issues. Okay, eliminating workers who did a poor job on Q1 didn't affect the interrelated agreement on questions Q2 and Q3. So the idea of this is, if you don't pass Q1 and Q2, you're out. Okay, I cut you because you're just not doing basic stuff. So we can still build a classifier that identifies tweets and are interesting to a majority of users. Not the best ideal because we want something really, really cool, but at least we know how to pinpoint and identify the problems with the task. Okay, into the last part of the talk, which is the overall area of algorithms and work quality. So how do we measure work quality? We basically are going to compare the workers' labels versus known, correct, and trusted labels, other workers' labels, or we're going to build a model. We're going to predict the set of labels. And it's also good to verify the workers' labels as well. You can verify someone else's labels, or you can use a tiered approach. So we use low-level workers for certain tasks, and more experts to the other one, et cetera, et cetera. So let's talk about a few design patterns. One is called Iterative Refinement. So this is someone does something, and then you have another worker who is going to fix a little bit and do something, and then you have another worker who's going to fix on that and just until you get this stuff right. Another one which is very nice is called Find, Fix, Verify. So this is by Michael Bernstein, who has this cool demo project called Soylent. So you have one crowd who's going to find the problem, separate crowd is going to fix the problem, third crowd is going to verify the solution. Okay. And then you have the other one, which is do verify. This is more of a tier. So someone who is an expert identifies a problem and then fix it. Okay, so if I'm a rookie, I made an error, my supervisors say, no, this is an error, this is how you fix it, and you're done. So those are usually the three patterns that people use to make sure that the quality is on the task is there. How you compare to known answers, which is usually called goal, honeypots, or verifiable answers. So assumes you have known answers. You have to produce these answers. Okay? So you have to hire the experts. They're going to create the goal or the honeypot, and then you have to match if I pass or it didn't pass. This is very similar to a test. Now, there's a cost and benefit. The first one is you have to produce this, which are not trivial and they're not cheap. And then you have to spend a certain amount of work kind of reproducing them, because you don't have a goal set of honeypots and then you're done, because people are going to guess your honeypots. So you have to always maintain these honeypots. And then they have to be done in certain ways that people are not going to say, oh, come on, this is a honeypot, then I pass the honeypot, and then you kind of watch TV while you do the rest. Another way is to compare to other workers. So it's kind of consensus, plurality, redundant labeling. And again, cost benefits, you're going to ask 5 people. Yeah, we're going to lose a bit of money here, but we just need to make sure that the labels are good. I'm going to speed up a little bit. Another one is to create a qualification test. So I'm going to pre-qualify you. This is good. So I'm going to weed out people who are not, don't have the expertise to do my task. But the disadvantage, again, is expensive. I have to create a qualification test. It may turn off people. So it's like, oh, I don't want you to pre-qualify me. I'm able to do the work. You have to refresh the test. You have to retest people again and again, right? And in certain cases, like, for example, how do I know that you're good at doing label for relevance? It's very, very difficult to create a qualification test. What are the algorithms that people use in practice? So you have the 3 references there, but mainly majority vote kind of works very well in a lot of the cases. Then there's a bunch of kind of expectation maximization algorithms as well as maximum likelihood, all different approaches. Panos Ippolitis, who is NYU, he has this also an open source version of Get Another Label, which is going to decide how many labels to use on a given hit based on the distribution of the previous hit. So it's going to be an adaptive. Then Vox Populi, who is going to kind of aggregate labels as kind of approximate to a goal set of a ground truth, and is going to weed out people who are kind of off the goal set. So it's going to remove poor performance workers. And then Programmatic Goal, this is a paper by the guys from Crowdflower, who are kind of spotting stuff that is not well done, and then you just remove that the data set. Active learning, it's an area that could have a lot of benefits from this, because what you want is you want to minimize the number of labels to achieve the accuracy rate of the classifier. So the idea is I'm just going to select certain subset. The problem that I see with active learning in label quality is if you don't get the right labels, your active learning is not going to work. But also you have to make sure that the workers are not going to starve. Okay, so you cannot be a lot of selective on the number of workers, because you're going to lose them and then you're going to be able to finish your task. So there are suggestions on how to keep the workers occupied. You pay for a waiting room, so while you're waiting for the next thing, just hang on. You can parallelize some of the labelings, and you can use the workers to do other stuff in the meantime. Now, things that we at Microsoft have been working for the last 3 or 4 years is this notion of adaptivity, which it's pretty cool. So it's this entire research area called explore exploit. And you want to explore and exploit at the same time. So there's a trade-off between quality and cost. So you want to minimize the cost, but you want high quality. This is exactly what real-life people want to do. And you don't want to spend a lot of money, but at the same time, I want high quality. So how we do this? So we used, again, the framework called Explore. So you're trying a lot of alternatives and to see which one is going to work best. And you can exploit once you have an alternative that has been performing well very well in the past, and you just exploit that particular strategy. Here's an example. This is brand new stuff at Microsoft. We call it adaptive exploration. So you say that you have the query Facebook and you have facebook.com. How many workers? Probably 1 worker. But for the query Solar Storms, that website, maybe 5 or 7. Okay. So how can I kind of move? How can I change how many workers and when to stop? So you have to have a stopping rule, when to stop, I get another label. And if you do this very well, you can build your honeypots automatically. Last slide. Takeaway, repeatable labeling quality at scale works, but requires a solid framework. If you don't have the framework, it's not going to work. There are 3 aspects that need attention: workers, work, and task design. It's important, pay attention. Labeling social data is very, very difficult compared to web data, like a web page or a traditional information retrieval document. It's important to know the limitations, your own limitations, and be ready to work with other folks. So there's a lot of skills that are needed. Okay, so social behavioral scientists, human factors, algorithms, economics, in particular how to do the incentives, distributed systems, and all the statistical stuff. And I'm done. That's my Twitter account. Thank you very much.